I'm going to talk about some of the tips and tricks of how to optimize the microcontainer, using usage of the microcontainer. Unfortunately, there's no MC introduction into it, so it's going to be pretty high-level stuff. Just presenting some entry points for you to try these things later on yourself, or get to me on the forums or mailing list to discuss things. I'm gonna go per sub-project, mention some of the tips and tricks you can use there, and hopefully we get some feedback later on from you, or I'm just gonna mention how some of the things that how we use them in JBoss AF. The first tips and tricks I'm going to mention is from the Reflect in MDR and Manage project. In the Reflect project itself, I don't know if there's actually a reflection abstraction. And currently we're using JDK's introspection, which is not that performant. But eventually we have a JavaSys based implementation, which is at 80%. And once we're fully there, it's going to be since the way how JavaSys works is it caches some of the things, it does bytecode reading for some of the things that you actually don't need to load the class and so on. And eventually, like I said, we are keen on implementing the Reflect part of the on JavaSys 100%. There's a bin info, which is what we use to analyze the class information of the beans or the services inside MC. You can somehow adapt or how you create the bin info. Currently, what we do is have three different types of what we expose. By default, we expose just properties. But if you want to actually check into the fields or private fields or so on, you can add a different bin info access mode. Or adding a new view of the bin info is pretty much trivial through the help of bin info factory or bin info creator. There's an MDR project where we store the metadata, and if you're actually hitting if you're hitting similar metadata over and over again, there's a add on top of it, and it's simply called MDR cache, which is just a sort of a caching abstraction on top of MDR. The third project that I mentioned is the Managed, which somehow optimizes how you interact between client and the server. So with a proper usage of meta type and meta values, you can minimize the throughput from client to server and vice versa. This is pretty heavy stuff, which in most of the cases, you're not actually going to see all these things unless you're implementing against the SPI of these mentioned projects. Another project that we use inside the MC is the VFS, Virtual File System. It abstracts how we look at the file system, meaning you're using the VFS API. It simplifies how you do the lookup for resources, meaning you don't have to ask yourself, is it a directory, is it a file, is it a jar, is it a nested jar, and so on. And there are a couple of things that you can optimize. It's most of the things are mentioned, most of the options are mentioned in VFS utils. You can, by default, what we do with nested jars is we copy them, we do a temporary copy, but you can do all of these features in memory as well, meaning you can handle nested jars directly in memory, no need for a temporary copy. The way how you read zips or jars, it's if you're constantly opening and closing the jar itself, it's not that performant. So we have something that we call a Reaper thread, meaning that we actually don't close the read of jars until we see that nobody actually uses that jar anymore. So it's on a separate thread, but you can either use it or not. By default, we are using the Reaper thread. And you can specify that your file system is actually case sensitive. So I think by default you're not using case sensitivity in VFS. In order how you hit things in VFS to URLs and URIs, it's just a matter of right VFS cache usage. So if you see in the JBoss AS itself, there's a VFS XML file which is where you configure a proper VFS cache usage. When you did different things, for example, if you hit directly virtual file API, it's not as performant if you're doing it through the VFS class, meaning that, like I mentioned in the slides, there's an exception handler on the VFS instance, and the root of the VFS is lazy created. You can configure VFS instances, whereas you're not able to configure virtual file instances. There's a nice visitor pattern API on top of virtual file. There's an assembled and in-memory protocols helping you, like assembled stuff is something Eclipse calls it distributed resources, meaning you can take different resources trees and map them together as a common root. So meaning you can just take different pieces. It's really useful for testing. We use a lot of them assembled in our deployers testing or WebDyn's testing and so on. Or in-memory is a useful protocol. For example, when you have generated bytecode for AOP, instead of creating a temporary file, you just stash the bytes in memory. And there are a couple of copy mechanisms you can use, like tempering copying, unpacking copying, and so on. The most interesting tips and tricks are for the kernel. The MC itself, like the state machine itself, is really minimum, and meaning you can just, I think it's really just a couple of like 50K, and you can take the Java Beans minimal schema and run the MC state machine on, for example, on the cell phone or something like that. It's really minimal state machine. You can optionally, you can use AOP, you can disable AOP by not providing by not putting the MC, AOP MC integration into the class path. We just recently added where you can specify which parts of the AOP you're going to use. So that's the @disable AOP. You can just disable point count matching, or you can just disable a lifecycle callback. And for example, if you're doing IOC dependency injection through the annotations, and you just, instead of checking for all annotation plugins, you can just specify which annotation plugin you want to use. In this case, I'm just using the @inject and everything else, so it's going to be much more performant. It's not going to go and look up to the all annotation plugins, just inject plugin. One of the controller modes is on-demand mode, meaning the bean is not going to get used unless some other bean demands that bean. Or, for example, you can have things called, you can have things used lazily. What we do is we create a proxy instead of actually pushing in a true instance of that bean. We push in a proxy, and the real bean gets deployed when you first hit the proxy. And you can, if you want to, like, for example, you can configure your kernel.